Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. 2 sum 2, input array is sorted, Leetcode 167. I've already covered the problem 2 sum in detail on the channel, so be sure to check it out. Use the I button or check the description for the link. The key difference here is that the array is already sorted, allowing us to directly apply the techniques we covered without needing to sort the array first. In this problem, we are given a one index array of integers, numbers, that is already sorted in non-decreasing order, and we have to find two numbers such that they add up to a specific target number. Let those numbers be at indices index 1 and index 2, where index 1 is less than index 2 and both the indices are more than 1 but less than or equal to length of the array. And since the array is one index, we have to return the indices of the two numbers index 1 and index 2 added by 1 as an integer array of length 2 containing the two indices index 1 and index 2. The tests are generated such that there is exactly one solution. We may not use the same element twice. Your solution must use only constant extra space. Then in example 1, for the given nums array and target equal to 9, we find the two elements 2 and 7 at indices 0 and 1 that sum up to the target. But since we have to return the one indexed array, we will add 1 to those indices. So our answer will be 1, 2. Now in terms of solution, one of the naive approach can be that we iterate over every pair of the array. For this, we'll use two nested loops, say with pointers I and j. The outer loop selects the first number and the inner loop checks all numbers after the currently selected number. And for each pair, we check if their sum is equal to target. And as soon as we find the pair that satisfies the condition, we will return their indices as one based array as our answer. Here for example, initially I is equal to 0 and j is equal to 1. So first pair we see is 0 and 1, which sum up to 1, which is less than 5. Then we move the j pointer forward, and the next pair we see is 0 and 3, which sum up to 3, again less than 5. Then we move the j pointer forward, and the next pair we see is 0 and 5, which sum up to 5. Hence we will return the pairs I plus 1 and j plus 1 as our answer, where I is 0 and j is 3. So we will return our answer as 1, 4. Now the time complexity of this approach is O of n square, where n is the size of the input array because of two nested loops. And the space complexity will be O of 1 as we are not using any additional data structure. And now the question is, can we do better? And the answer is yes. The bottleneck of the naive approach is that it exhaustively explores all possible pair of numbers in the array, resulting in the inefficient O of n squared solution. However, since the array is already sorted, we can use binary search technique to eliminate the need for checking every pair. In that case, we will just need one pointer, where in the outer loop, we select an element like we were doing earlier. And now, instead of scanning the rest of the array linearly, we'll use binary search to find its complement, that is target minus number, which will take O of log n time. So we iterate through the array with a single pointer I, and for each number we calculate its complement. And once the complement is found, we return the indices of the current number and its complement as a solution. For example, here we start with number 0 and check if its complement, that is 5, exists in the array, and it does at index 3. So we will return our answer as one indexed array, which will be 1, 4 as our answer. Now the time complexity of this approach is O of n log n, because for n elements in the array, we are searching for its complement, which will take log n time for each element. Hence the time complexity will be O of n log n. And the space complexity will be O of 1, as we are using few variables here and there. Another efficient approach we can use given the array is sorted is the two-pointer technique. Instead of repeatedly recalculating and searching for the complement using binary search, we can use two pointers, left pointer and the right pointer. The left pointer starts at the smallest number at the beginning of the array, and the right pointer starts at the largest number at the end of the sorted array. And we calculate the sum of the numbers pointed by the left and right pointers. For example, here the sum is equal to 0 plus 7, that is 7. And if the sum is equal to target, then we return the indices of these two numbers. However, in this case the sum is greater than target. Now which pointer should we move? Since the sum is greater than the target, we need to decrease the sum. To achieve this, we should move the right pointer inward, that is to the left. If the sum was less than target, we would have instead moved the left pointer inward, that is to the right. And we continue this process until the two numbers that sum up to the target are found. And in this problem, it is guaranteed that we will find the answer. But if it was not the case, then we would stop the iteration when the left and right pointers meet. Continuing with our iteration, now the sum is equal to 0 plus 6, which is still greater than target. So we move the right pointer inward to check for the next pair. And now the sum is equal to 0 plus 5 equal to 5, which matches the target. Hence we will return the indices left plus 1 and right plus 1 as our answer, which will be equal to 1, 4. Now the time complexity of this approach is O of n, because we are going through each element in the array only once, and the space complexity is O of 1 because we don't require any additional data structures. Now before we dive into the code walkthrough, it is worth noting that another approach to solving this problem uses a hash map. While effective, the hash map approach requires extra space, but here we avoid that entirely because the array is sorted, and the two-pointer approach already has a linear time complexity. Here is a quick code walkthrough of the algorithm we just talked about, with Java code on the left and Python on right. First, we initialize the left pointer to the start of the array or list and the right pointer to the end of it. Now we enter a loop that continues as long as the left pointer is less than the right pointer, and we calculate the sum of the numbers at the left and right pointers. If the sum is equal to the target, then we will return the array containing the left and right pointer indices. And since we are dealing with one indexed array, we will increment these indices by 1. However, if sum is less than the target, then we will increment the left pointer. And if the sum is greater than target, then we will decrement the right pointer. And in the end, if we can't find the solution, then we will return the array with values -1 as our answer. However, this case shouldn't arise as the solution is guaranteed. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.